Right, today we'll look at the second part of section 2.1. So yesterday we looked at how to convert between degrees and radians. Today we're going to look at how to find two things. How do we measure the length of an arc on a circle? And how do we measure the area of part of a circle? And the part is called a sector. Okay, so we'll kind of look at what that shape looks like and then how we find the area of it. All right, so we're going to start with this picture. Okay, what I've drawn it there is a circle, and inside the circle there's two angles. Okay, a lot of times when we label angles in trig, we use Greek letters. So that's what I've done here to label the two angles. Does anybody know what Greek letter that is? Circle with the line in the middle? Yep, it's theta. So the bigger angle I've called theta, the smaller angle, theta 1. Just two different angles. Each of those angles has rays that come out from the center of the circle and hit the circle here, here, and then here, and here. Between those points where the rays intercept the circumference, I've drawn the arc. So S is the arc that goes with angle theta. S1 is the arc that goes with angle theta 1. And I've labeled the distance from the center to the circumference as R because that's the radius of the circle. Okay. All the rays of the angle in this circle, they're all R because they're all from the center to the edge of the circle. Okay. Any questions on the picture? All right, so the first thing I'm going to tell you here is that angle size and arc size are directly proportional. Anyone tell me what that means without using the word proportional? Like, let's say somebody didn't understand what proportional meant. What does that mean if I say that angle size and arc size are directly proportional? Yep.
They relate to each other?
They have a relationship to each other. Can you be more specific about the relationship? If I say they are directly proportional? Not sure. Maybe.
Like saying they're the same, or?
They're not necessarily the same, but there's a relationship. But they don't always have to be exactly the same. The relationship has to do with this changing. As one changes, the other changes. But I want to be a little bit more specific than saying, as the angle changes, the arc changes. That's true, but I want to be more precise.
As the angle gets bigger, the arc gets bigger with it?
Yeah. So what basically happens is if you double the size of the angle, you double the size of the corresponding arc. Think about if you had a circle and you drew a 90-degree angle, there's your arc. That's a quarter of the circle. Now, if I double the size of that angle, make it 180 degrees, I just doubled the size of the arc. Now it's a half circle. Right? If I made the angle half as big, I make the arc half as big. Okay, so angle size and arc size are directly proportional in a circle. So because they are proportional, that means we can set up a proportion. Okay? That means we could do something like, if we knew a fact to start with, just as an example, 1 foot is to 12 inches. As now I could make something up like how many inches in 13 feet. I can set up a proportion and solve it. And it's all because I knew a fact to start with. Right? These are angle size and arc size are directly proportional, so this concept applies. If they weren't directly proportional, you couldn't set up a proportion. Okay? But they are. The key that we need, though, is this. Not 1 foot, 12 inches. We need a fact to start with. And using that starting fact, we can figure out anything we want. Just because I used a 1 and a 12, that doesn't limit the number I can put here and here. I can put anything there. If you wanted to know 17.5 feet, I could still use this conversion factor to help me. So I can use any number I want. I just need something to start with. So that's what we have to figure out. something to start with. So we're going to suppose that theta 1 equals something. Just like we can suppose 1 foot is 12 inches. It's a definition. Well, does anybody remember what I said yesterday about if this arc is a certain size? Actually, I'll say it a different way. If this angle is a certain size, then this arc is the same as something else in the circle. Does anybody remember what we said, how big this angle would have to be to make this arc exactly the same size as something else? Had to do when we defined the very first thing we talked about with radians. If we make that angle a certain size, then we will automatically know how big that arc is. Yep?
1 inch.
Well, inches in a measure is not an angular measure. Inch is a linear measure. So, not 1 inch, but, yep.
Is it like 360 or 0?
No, we were closer before. Closer before. You want to take another guess? How do we measure angles? What's the label on it?
Degree.
That's one option. What's the other option?
Radian.
Yeah, radians. So we said yesterday that if you make this angle 1 radian, then this arc is the same size as what? If you make that angle 1 radian, this arc is the same size as something else. Yep.
The radius.
The radius, exactly. And that's the starting fact we can use that would help us figure out where we begin. If we let theta 1 equal 1 radian, then this arc S1 is automatically the same size as the radius. We would know the size of the arc. So that's the connection between angle size, the angle, and the arc. If the angle is 1 radian, then the arc is equal to r. So we're going to use these two facts to kind of help us build a formula. Those two facts are going to be the left-hand side of my formula. Okay? The right-hand side is whatever they give you in the problem. Okay? That's what you have to figure out. But the left-hand side is the stuff you start with. So I said these were directly proportional, so we have to set up a proportion. Okay. And the proportion we're going to set up is going to involve 4 things. We have a numerator on the left and on the right. We have a denominator on the left and the right. Here's the 4 things. An arc, an angle, an arc, an angle. And we can set it up exactly the way I just said. We could set up this arc compared to that angle equals this arc compared to that angle. That's what it means to set up a proportion. You have to set it up the same way on the left and on the right. Arc to angle, arc to angle. And there's many other ways you can set it up. But that's one way to do it. And now in that proportion, we're going to fill in a couple facts. We're going to let S1 equal R, and we're going to let theta 1 equal 1. And that's going to give me my left-hand side, which is the starting point, to figure out anything else you want to know. Okay. So let's fill that in. So S1, I'll do it over here, is R. Theta 1 is 1. There's your 1 foot, 12 inch type of fact. That's the starting point. Equals, now on the other side, we're not going to fill anything in, because when we're given a problem, we'll have stuff to plug in. So just leave it as S over theta. Okay. Now, how do you solve a proportion? What's the technique you use? Yep.
Cross multiply.
Cross multiply. S times 1. What's S times 1?
S.
Yeah, just S. And then R times theta. Well, just R theta. R times theta. And that formula that I just wrote, that is the arc length formula. That's how you calculate the length of an arc. So what do the letters stand for? Well, S is an arc, okay, in a circle. So that's an arc. R, what do you think R stands for?
Radius.
That's your radius, okay, in a circle. And what about theta?
Angle.
That's an angle. We have to be careful. Because way back when we figured out this formula, we assumed something about our angle. We assumed that we were working in what units?
Radians.
Radians, right here. This whole thing was built on the idea, built on the assumption that everything was in radians. So when you use this formula, it has to be in radians. If you're given an angle that's not radians, that's your first thing you got to do. Change it to radians. So the way we use the formula, there's 3 things in it. The problem will always give you 2. You have to find the third one. Okay? So we'll go through one of each type. I'll start off by giving you a radius and an angle. You tell me the arc, and then we'll switch it up and find, maybe I'll give you the arc and I'll give you the radius, and then I'll ask you what's the angle.
So if it gives you an angle, you have to turn it into radians?
If it's not already.
Okay.
Sometimes it will be. Like in this problem. So sometimes they can give you a problem and just write out everything, or they could give you the exact same problem and really just make a sketch. This sketch conveys pretty much exactly the same thing as all these words. You just have to get used to looking at it either way. Okay. So the question is to find the length of an arc, and it says you have a circle, and inside the circle there's an angle of pi over 3 radians. The radius of the circle is 4 inches. Find the length of the arc. So if you're a more visual person, you can draw this out, but really all you need is the formula. But if you're wondering what are we really finding? Well, draw an angle on a circle. The angle is pi over 3 radians. The radius of the circle, 4 inches. You are finding this. The length of the arc in black. Okay, so first thing we have to figure out is what formula should we use. Okay, up to this point, you've only learned one formula, and that's the formula for the length of an arc, so that's the one we use. Now we're going to take what we're given, fill it in the right spots. So Brady, let's start with pi over 3. What letter is that going to get filled in for?
Theta.
Yeah, that gets filled in for theta. So I'm going to fill that in. Now, radius of 4 inches. Abby, where does 4 inches get plugged in?
It's for the R.
Yeah, radius, 4 inches. So times 4. And S is what we don't know. Any questions on that? If you want to make 4 a fraction, you can. You don't really need to. But you just multiply fractions straight across. You don't find a common denominator. So the arc length is 4 pi over 3. And we have to put the right label on this. We just found S. S is arc length. In this problem, what were my lengths measured in? What unit?
Inches.
Inches. Okay. All length measurements in this problem were inches. So that is 4 pi over 3 inches. If they wanted the arc as a decimal, just type it in and round it off, just like we did in last night's homework. So that's about 4.19 inches. And that's how you find the length of the arc. Any questions on that? All right, so let's try another one. This time I just drew a picture rather than writing it all out in words. Okay, so find the length of that arc. Okay, once we learn the other formula is going to be for area. Okay, we're not finding the area of that. We haven't talked about how to do it yet. Once we do, you're going to have to decide, is this an area problem or is this an arc length problem? Well, read the directions. Find the length of the arc. It's an arc length problem. So Caitlin, since it's an arc length problem, can you give me the formula for arc length? Yep, S equals R times theta. And now we're going to fill in what they give us. Let's start with 8 feet. How about Cassandra? Where's the 8 feet going to go?
R.
Yeah, that's my radius. It's measuring that distance. And Jordan, how about theta? What would I plug in for that?
130.
I agree with you that the 130 is an angle, but it's not theta. How come? You can help him out. Why? If you plug in 130 and do 8 times 130, we're going to get the wrong answer here. Yeah. Yeah, Lauren, yeah.
Because you have to convert it to radians first.
Right. So off to the side, I'm going to convert, or actually I can really do it right in the problem. I'm going to take the 130 and I'm going to convert to radians. Ethan, how do I convert to radians? What do I multiply by?
Pi over 180.
Pi over 180. There's my angle. So if you want, you could do that off to the side, or you can just build it right into the formula. 130 times pi over 180. There's the calculation to convert to radians. And that's what we need to do out. Any questions on that? Okay, inside the parentheses, what can I reduce 130 and 180 by? Yep.
10.
Yep, can reduce them both by 10. And now I have 8 and 18. Those are both divisible by, well, Jamaica?
13 and 18.
8 and 18. Because 8 is in the top, 18 is in the bottom, so we can reduce.
Oh, that's right. Is it 4?
4 goes into 8, but 4 doesn't go into 18. So we can't reduce by 4.
2.
2. So we can reduce 8 by 2. We can reduce 18 by 2. And now we're left with a calculation that's a lot easier to do in our head. So 4 times 13 gives me 52. So 4 times 13 times pi divided by 1 times 9. It's the only thing at the bottom. You can't reduce 52 and 9 don't have any common factors. Okay, so that is our arc length. 52 pi over 9. And what should be my label on that? Feet. Right? That's a length. In this problem, the length unit was feet. If you wanted a decimal, you just plug it in, just like we did the last one. Okay, any questions on that one?
Yeah, what's the symbol with the circle and minus and what's it called again?
This Greek letter, theta.
Theta.
Yep. It's a Greek letter, theta. Okay, any other questions on that? All right, so let's switch it and try finding something a little different. So I'm telling you the arc length is pi over 4. The radius is 12. Find the angle. So I've already written the formula, S equals r theta. Colby, let's start with pi over 4. What letter does that get plugged in for?
S.
S. That's the arc length. Okay. The directions are to find the angle, so we can just leave theta. And the only thing left is to fill in for r. And the only number left is 12. Okay. So now we just have to get theta by itself. Okay. How would I move the 12 to the other side to get theta by itself? About, right?
Divide by 12.
Yeah, divide by 12. Dividing by 12 is the same as just putting a times 12 in the bottom of a fraction. If it's in the bottom, it's dividing. So I'm left with pi over 48. Okay, so as I said, we're left with pi over 48, and that's my angle. Now, that's an angle. So what's the label on that?
Degrees.
Well, this formula always gives you an angle in what units? Yep.
Radians.
This formula always gives you an angle in radians, so there's nothing else I need to write. You don't have to put RAD. Now, if this was a multiple choice question on a test, let's say all the multiple choice answers were listed in degrees. You would have to do everything we just did, okay? Get this answer, and then your last step would be to change this to degrees. Because if the multiple choice answers are listed in degrees, you've got to make your answer in degrees to match up. Okay? So you'd multiply by 180 and divide by pi and see what you get. If this is just a short answer question, and the directions don't say to use degrees or radians, I would just leave it like that. You don't have to change it to degrees. The directions didn't say it. Any questions on that? Okay, so the last combination you could have for this type is find the radius. So this time they're giving you an arc length. They're giving you an angle. We're going to find r. Okay. If I wanted, before I even start, what am I going to have to do here at some point? And I might as well do this right away, get it out of the way, so I don't have to worry about it later. Yep.
Convert 36 into radians.
Right. I'm going to have to convert 36 degrees into radians. Okay. If you go through all the work and do it out, that's what you'll get. Okay, if you multiply by pi and divide by 180, 36 is actually a multiple of 180, 36 times 5. Okay, so 36 degrees is pi over 5 radians. Okay, now let's fill in. So S, I'm given that, 13 feet. R, I don't know, that's the question. And the angle, now we've changed it, is pi over 5. Okay, so our goal is now to get the pi over 5 on the other side. There's a way to get the pi and the 5 on the other side at the same time. Does anyone remember what you can do on both sides that'll cancel the pi and the 5 at the same time? Yeah?
Don't you like do the reciprocal or something? Or is
When you say do the reciprocal, do what with the reciprocal?
like put the pi on the bottom and the 5 on the top and then times it on the other side?
Times it, exactly. So you multiply both sides by the reciprocal. So That's going to cancel there. And we're left with 5 times 13 over pi. We should do out 5 times 13. Okay. And 5 times 13 will give me how much?
65.
65. 65 over pi. Now, what is that again? That's the, what did we just solve for? Radius. Radius is a length. What were my length units in this problem? Feet. So you have to keep in mind what you're solving for to know what you should put for a label. And if you wanted it as a decimal, just do 65 divided by pi button, and that's it. Okay. So any questions on the first formula for arc length?
S stand for?
S is arc length.
Arc? Okay.
Yep. So S is your arc length. R is your radius, and theta is your angle. Okay. So second thing we're going to look at is how we can find not the length of an arc, but how we can find the area of a sector. A very simple way to think of a sector, it's like a piece of pizza. It's got 2 edges that are straight, and the top edge is curved. Okay, that's a sector. So it's not quite like a triangle because the third side is an arc. It's not a line segment. Okay. So I'm starting off with pretty much the same kind of diagram. I have theta and theta 1. Okay. And from each of those angles, the rays, or each of those vertices, the rays come out, hit the edge of the circle right there, and it forms a region, okay, called a sector. So I'm looking at this. Theta corresponds to area A. Theta 1 corresponds to area A1. I just didn't have enough room. So to figure this out, we need a starting point. We need some fact that's going to help us. Well, first thing I'll tell you is that angle size and area size are directly proportional. Okay? That means the same thing as it did with arcs. If you double the size of this angle, you're going to double the size of the area that's covered. If you make the angle half as big, you're going to make the area covered half as big. Okay? So because they are directly proportional, that means we're going to be able to set up a proportion just like we did before. The key, though, is we've got to figure out the starting fact. We've got to have a fact to start with, like 1 foot 12 inches on the left. Then we can put anything we want on the right and figure out whatever we need to. All right, so we can't let theta 1 equal 1 radian again. That trick doesn't help us this time. We have to let theta 1 equal something else. So, give me a hint. How much of the circle did I just shade in by creating an angle? How much of the circle is that? Do you mind?
1/4.
It's 1/4 of the circle. So what does that mean this angle would be? That's a 90-degree angle. I'm going to go a little bit bigger. I'm going to draw another circle. And now I've created a sector that takes up how much of the circle? Yep.
Half of it.
Half of it, which is 180 degrees. Well, now I'm just going to jump to the final part. Here's my initial side. And then here is my terminal side. So what I've done is I've drawn an angle that's now so big, it takes up how much of the circle? How much of the circle is shaded in there? All of it. What would be the size of the angle in the circle that would take up all of it.
360 degrees.
360 degrees, which is the same as what in radians? 2 pi. So that's going to be our starting fact. If you have an angle that's so big, it takes up the whole circle. If your angle is 2 pi, then your area is the entire thing. And we should know how to find that area. Okay? We already have a formula for the area of a sector that's so big it takes up the whole circle. That's the formula for the area of a circle. So, what's the formula for area of a circle? No 2 in it. The 2 is usually when you write circumference, like 2 pi r.
I'm gonna try. Is it like radius squared times pi?
Yeah, it's pi r squared, right? Radius squared times pi. Okay. So now we've got a fact to start with. We know that if the angle is so big, if the angle is 2 pi, then the area is pi r squared. There's the connection. Angle is 2 pi, area, whole thing, pi r squared. 1 foot, 12 inches. There's your starting fact. So let's set up a proportion and see if we can solve it. So we're going to suppose that the angle is so big, it takes up the whole thing. And if it does, then the area covered would be pi r squared. Now, if you didn't know the formula for the area of a circle, then you're kind of stuck. I'm not sure how you would figure out what to start with. Okay, so let's set up a proportion. Can anyone give me a proportion involving this, that, and that? And there's lots of ways you can set it up. Just however you do it on the left, you have to be consistent on the right. Anyone? Yeah, Nathan?
Area over theta
Okay.
equals theta 1 over a1.
Okay, you weren't consistent though. You put area on the top on the left, so you got to put area on the top on the right.
There.
So can you fix the right side for me?
Yeah, just be theta 1 over a1.
No, you can't put theta 1 over a1.
I mean the other thing, a1 over theta 1.
There you go. A1 over theta 1. Area over angle, area over angle. Just have to be consistent on each side. Yep, good job. Okay. And now one side of that fraction, we've got stuff to fill in. We're going to fill in 2 pi for theta 1. We're going to fill in pi r squared for area 1. Okay. And let's see what happens. So we have a over theta equals pi r squared over 2 pi. Now, we're going to do the same thing we just did before. How do we solve a proportion?
Cross multiply.
Cross multiply. Before I cross multiply, though, I can actually reduce a little bit. Anybody see something I can cancel before I cross multiply? Yeah.
Pi.
Yeah, exactly. You can cross out the pi's. And now let's cross multiply what's left. A times 2, which we normally write as 2a, equals theta r squared. You can put theta r squared theta, same thing. But I don't want a formula for double the area. I want a formula for just the area. So how would I get that 2 on the other side? Yeah.
Divide.
Yeah, divide by 2. Dividing by 2 is the same as multiplying by what number? A half. Okay, that's how our book writes it. So that is the formula for the area of a sector. It's 1/2 r squared theta. Okay, so A stands for area. R is your radius. And theta, what's theta? That's my angle. Anything special about the angle? What do we have to be careful about? In radians, way back at the beginning, look at the suppose. We suppose that this angle was 2 pi. There's no degree symbol on that. So it's 2 pi radians. So we got to make sure this is in radians. Okay. So now when you have a problem, you have to decide, are they asking me to find area? If they are, use the formula we did before. I'm sorry, use the formula we have now. If they're asking me to do arc length, you've got to use the formula we had before. Same deal, 3 variables, they're always going to give you 2 out of 3. You have to find the third one. Okay, so let's start with this one. It says, find the area of the sector. Okay, so the directions in the problem, I think, are pretty clear, whether it's an area problem or an arc length. Find the area. So it's an area problem. Liz, can you remind me, what's the formula we just came up with for area of a sector?
So area over
just the final. Once we took that proportion and I put a box around it and labeled all the variables, that's the final formula you want to use.
Is it the half?
Mm-hmm.
Radius squared, and then the angle radius.
And then the angle. Okay. So there's your formula. And now we have to decide what goes where. Jillian, let's start with 4 centimeters. Where's that go?
Radius.
Yeah, that's going to go in for your radius. And then pi over 6, that's my angle. Am I okay to plug pi over 6 in the way it is? Yeah, there's no degree symbol on it, so we know it's radians. Now there's a lot of arithmetic, so you can do a couple things in one step if you want. What's 4 squared? And then half of 16? 8. So we can do all that in one step. So we get 8 times pi over 6. 8 and 6 can both be reduced by 2. So we get 4 pi over 3. Now, someone remind me, what is that again? The 4 pi over 3 is the
Area.
It's the area. So we have to put the right label on that. Looking at the units we have, how would area be measured in this problem? Centimeters squared. Yes. Okay. So 4 pi over 3 centimeters squared. Okay. Any question on the type where I give you the radius and the angle, you tell me the area? Okay, let's try a different one. Now, I'm telling you the angle and the area, and I want you to give me the radius. Now, how would you know in this problem if you should use the arc length formula or the area formula? Because the word area is not on the board anywhere this time. Neither is the word arc length. How would you know, based on what's given, which formula to use?
It gives you an area.
It gives you an area. It's 8 pi over 3 square inches. That's not an arc length. That's an area. So, use the formula for area. Okay, before I just start plugging stuff in, anything that I might want to deal with get it out of the way first. Yeah.
Convert 45 into radians.
Yep. And anyone tell me what 45 degrees would be in radians? We know 180 is, how much is 180? Pi. And 180 divided by what gives me 45? 4. So this is a quarter of pi. Pi over 4. Okay. If you want to multiply by pi and divide by 180, you can do it all out. But the way I think of it is, that's a quarter of 180. I know 180 is pi, so it's a quarter of pi. Pi over 4. Okay, now I'm ready to plug in. So I've got 8 pi over 3 equals 1/2 r squared times pi over 4. So there are a lot of things you have to get on the other side here. The 1/2, the pi, the 4, and then the square. We've got to get rid of that at the very end. But we can move one thing at a time. So let's start with pi over 4. What could I do on both sides to get rid of the pi and the 4 on the right? And we did this earlier in another problem. Nathan?
So you put on the right side 4 over pi times pi over 4.
Exactly. So
And
times.
on the left,
Yep. Could you just say again what to put right here?
4 over pi.
Exactly. 4 over pi. And same thing on the left, he said. 4 over pi. Pi's are gone. 4's are gone. Pi's are gone. Okay, so we just canceled out a lot of stuff. Pacey, what's on the left-hand side now?
4. Oh, I need 32 over 3.
So we get 32 over 3 equals 1/2 r squared. Okay, so that's better. We got some stuff away from the r. Ben, what else do I have to move on the other side away from the r? Yep, the half. And how would we get the 1/2 on the other side? Well, what do you do anytime you've got a number in front of a variable? Like if you had that.
Divide.
Yeah, you divide by the number in front of the variable. So what's in front of the variable here?
R squared.
In front of that. I'm looking for like the coefficient.
Like half.
Yeah, half. So you divide, in this case, you would divide each side by
Half.
a half, yep. Which dividing by a half is the same as multiplying each side by 2. I think it's easier, in this case, just to think about doubling that side, and then I don't have to deal with fractions. Okay, so now I'm left with 64 over 3 is my radius squared. Okay, that's not my radius, it's squared. So Kyle, what do I have to do now?
Find the square root of 64 over 3.
Yeah, find the square root of 64 over 3. So we're going to take the square root of what's on the left, take the square root of what's on the right, and that cancels. And now when you take a square root of a fraction, the way you do it, you take the square root of the top and bottom separate. The top is nice. What's the square root of 64? 8. And now numerically, that's our answer. There's only one thing wrong with leaving an answer like that. What's wrong with what I just wrote there? Yeah.
The square root's on the bottom.
We left the square root on the bottom. Okay, so arithmetic, you're not supposed to leave a square root on the bottom. Does anyone remember how you fix that? can leave it in the top, just not the bottom.
Isn't it like square root over 3 or square root over 3 times that?
Yeah, you're gonna take what you have, and you can multiply it by something, but whatever you multiply by, it's gotta be the same in the top and the bottom. If it's not, you're changing your answer. I'm gonna multiply by that over that. So really, I'm just multiplying by 1. Same thing in the top, same thing in the bottom. But the way I wrote it, watch what happens. 8 times the square root of 3 in the top. Square root of 3 times square root of 3 is square root of 9, which is 3. So now we've got our final answer. We've got it written in a way that's nice. Okay, that's about, I think, the hardest combination of problems you would have today, because there's a lot of simplifying in it. Okay, that's my radius. My radius is a length. Length is inches. Okay, so 8 square roots of 3 over 3 inches. If they wanted the answer as a decimal, then what I would have done way back at this step is I would have just typed that into my calculator right there. Okay, but if they don't want it as a decimal, that's how you got to do it. Okay, any questions on that? All right. Okay, so try that one on your own. That's the last combination you can have. I'm giving you the area, I'm giving you the radius, and I want you to find the angle. Right, so let's take a look at what we got. Okay, step 1, decide if you should use arc length or area formula. Austin, what should I use here?
What's that? Sorry.
Which formula should I use here?
The arc length.
Okay, and why do you say arc length?
Alright, you should use the area.
Area? Why do you say area?
Because you gotta find the theta.
I agree you have to find theta, but the arc length formula also has theta in it. But I couldn't use arc length here, yep.
Because it gives you an area.
Right, you're given an area, that's why you have to use the formula for area. So area equals 1/2 r squared theta. This time you don't even really need to figure out which one is which, they tell you. Area is pi over 2. Radius is 3, I'm going to square it right now. So 3 squared is 9. Yeah, I also made it a fraction at the same time. Times theta. Okay, to multiply together what you have on the right side, but don't even write it as a decimal. It's a lot easier if you don't use decimals here. Because if you do it this way, you get 9 over 2 theta. And then all I have to do is multiply each side by what? To get rid of the 9 over 2. 2 over 9. I don't have to think about dividing by 4.5. That's going to be really hard to do without a calculator. So times 2 over 9, times 2 over 9, and the 2's cancel. Okay, so I'm left with pi over 9. Okay, what's pi over 9? That's, what did I just find in this problem? I found theta, which is it's the angle. So my units on pi over 9 would be radians. Do I have to write that?
No.
No. Question on that one? Right. So in the homework tonight, there's going to be some problems like we just did. Then they're going to give you a couple of word problems. Okay, I think either the first or second one has to do with a clock. Okay, and they're going to ask a question like, from noon to 4, how far does the tip of the minute hand move? What kind of question are they really asking there? From noon to 4, how far does the tip of the minute hand move? That's really what?
And arc length question?
That's an arc length question. It's an arc length question where the length of the arc is how far the tip of the minute hand moves. The radius, it's just the length of the minute hand. But then the question is the angle. They don't have to give you the angle. If they tell you from 12 to 4, you should be able to figure that out. Anyone tell me how you could figure out the angle between 12 and 4? Because clocks are uniform, right? The movement between every hour is the same. So that helps. Yeah.
Just do 360 divided by 12.
Hey. Yeah, if you do 360 divided by 12, that tells you how many degrees the minute hand moves from 12 to 1 per section. Well, you've got 4 sections. So 30 times 4, that's a 120 degree angle. And now if you're going to use the formula I taught you, which is probably what you're going to try, you'd have to change that to radians. Okay? But that's the idea. They give you another problem about a pendulum swinging back and forth. They're going to tell you how long the pendulum is, and they're going to tell you how much of an angle the pendulum is swinging. They want to know how far the tip of the pendulum is moving. What kind of problem is that? How far the tip of the pendulum moves? Is that an arc length or area problem?
That's another arc length.
Yeah, it's just another arc length problem. The radius is the length of the pendulum, and the angle, they'll tell you how far it swings. So there's a couple, I think the last 4 problems are word problems like that. But there's a couple hints on 2 of them. All right, so homework, it's on page 99. 71 to 87, just the odds. 91 to 94, odd. Okay, tomorrow I will be after school for extra help. On Friday we have our first test on section 1.1, that's the distance and midpoint. And then everything we've done so far this week, and the last part of section 2.1, which we'll do tomorrow.